Hello everyone. Today I'm going to talk about a timing constraint in a circuit. Now firstly, let's remind ourselves some definitions. The propagation delay. Now the propagation delay of a gate or a circuit is the maximum amount of time it takes for it to stabilize its output upon changing its input. As for the contamination delay, which is also called the minimum delay, is the minimum amount of time it takes for the circuit or the gate to start changing its output upon receiving the input. Now you may ask, why is the propagation delay called? Why is the maximum delay called propagation delay? Because it propagates. And as for the minimum delay, which is called contamination delay, because it contaminates. Now, as for the notation we're going to use here, when we're saying TPCQ refers to the propagation delay of the clock to Q of the D flip-flop, which means it is the maximum amount of time it takes for the D flip-flop to output its changed value upon receiving the rising clock edge. As for TPD is the propagation delay of the combination of the circuit. Jesus. As for TCCQ, it is the contamination delay of the clock to Q, and TCD is the contamination delay of the combination of the circuit. Now there's one more term, which is the T setup, and if you remember, it is the amount of time it takes the amount of time it needs for the input. The input of the flip-flop needs to hold so that the flip-flop before the rising clock edge, so that the flip-flop can read the right input. Now, the first timing restraint that we need here is called setup time violation. It's called setup time constraint. Now, if you look at this simplified graph, what is the necessary amount of time for us or for all the D flip-flop here to receive its input to ensure that it receives the input upon the next rising clock edge. Now, if we go from a rising clock edge, you'll see that the information from the clock will go up out of the D flip-flop, which takes the TPCQ time, which is the propagation delay of the clock to Q, and then it will go through the combination delay, which is TBD, and finally, since the flip-flop needs to have more times to set up, we also need to add a setup time. So here we have our equation that describe our setup time delay, which is our minimum clock time, has to be larger or equals to the sum of these three. We usually don't take the equal sign, but in real world you can never achieve equal, so this part is fine.